Hi everyone, welcome to the last lesson of Unit 10. Can you believe it already? Yes, so today's the last lesson of Unit 10, and on Friday you will see the Unit 10 test on your plan. There's a Unit 10 review if you want to check that out in the review folder of Unit 10 on OMHS. These notes are available on OMHS as well as the key. You're welcome to download them, print them, follow along, whatever makes you happy. We are going to be covering the last formulas that we need for circles. And those formulas mostly have to do with lengths of segments. So there's three different ways that you might see circles and their segments. The first way is maybe your chords are intersecting inside the circle. And in Wednesday's class, we learned how to calculate the length or the measure of an arc or the measure of an angle when our chords intersected inside the circle. Today we're going to talk about their lengths. So if we have segment A, segment B, segment C, and segment D, if these chords are intersecting in the circle, they form a relationship between those parts. And that relationship is going to be A times B equals C times D. So you can say piece times piece equals the piece times the piece. It's pretty easy to remember, I think. Now, what happens if the secants are intersecting outside the circle, like in this picture? And in the last class, yes, we saw this picture, but we were calculating the measure of angles and arcs. This time we're going to talk about the length of each piece of each segment here. And the way I remember this is I say the piece on the outside times the length of the whole thing will equal the piece on the outside times the length of the whole thing. If you can remember that relationship, then that makes it pretty simple for both type 2 and type 3 pictures that you see here. So in the first secant, the piece on the outside here is A, that's pretty simple. But then the length of the whole thing is from here to here. And this is why we had to learn segment addition way back in Unit 1, because I have segment A and segment B making up the whole thing. So it means the length of the whole thing is A plus B. With our other segment, let's change colors. The piece on the outside is C, and the length of the whole thing is from here to here, which would be C plus D. So we're going to multiply that times C plus D. So if you can remember outside times whole equals outside times whole, then you already know the relationship for the type 3. So looking at the type 3 picture, here you have the piece on the outside, that's A, and the length of the whole thing just happens to be A still. For the secant that we see, the piece on the outside is B, and the length of the whole thing is B plus C. So now A times A actually gets simplified. So if you're looking at like a textbook or OMHS, they're not going to say A times A. Instead, what they're going to write is A squared. But that's really the outside times the length of the whole thing. It's just in this case, the piece on the outside happens to be the same as the length of the whole thing. Okay, so three ways you might see it. You might see two chords intersecting inside the circle. You might see two secants intersecting outside the circle, or you might see a secant and a tangent intersecting. So if they intersect inside the circle, you just multiply each of the pieces together for each part. And then if you see the intersection happening outside the circle, you'll just take the piece on the outside times the length of the whole thing. So let's look at some examples. In number 1, I see two chords intersecting each other. The intersection's on the inside. So I can just say, okay, this piece times this piece will equal this piece times this piece. So we can set up our equation. 14 times 15 equals 10 times x. Well, 14 times 15 is 210, and 10 times x is 10x. Divide both sides by 10, and there we go. X is 21. Easy as that. What happens if one of them is an expression? Not a big deal. I would, however, caution you, because you don't want to forget any distribution. Anytime you see a piece of it as an expression, go ahead and put parentheses around it. So in this one, we can say, okay, 6 times 6 will equal 4 times 5x minus 1. And when you put the parentheses around that 5x minus 1, now you can remember to distribute. So we get 36 equals 20x minus 4. I'm going to add a 4 to both sides. Divide both sides by 20. And if this was multiple choice, 2 would be an option. Please be careful though. Question says find the length of BD. So take that 2 and plug it in for BD. Okay, can't quite plug it in right away. Or plug it in here for 5x minus 1. So 5 times 2 minus 1. 10 minus 1 is 9. So this piece is 9. So that means the length of BD is 4 plus 9, that whole thing. So your final answer is 13. If I were making this a multiple choice question, I would have one of the options be 2. One of them would be a 9. One would be 13. And the fourth option would be something completely random. I don't know, 12.6. I don't know. It'd be something random. So just be very careful. Make sure you're answering the question. All right, now that you've seen me do 2 examples, go ahead and try number 3 and try number 4. Don't forget your parentheses. You don't want to forget to distribute. Okay, so right now you're going to try number 3 and number 4. Try that now. Okay, so for number 3, you should have gotten x equals 11. You did 24 times x plus 7 and 27 times x plus 5. Distribute that 24 into your parentheses and distribute that 27 into the parentheses. And following the algebra, you should end up with x equals 11. If you didn't get x equals 11, go ahead and double check your setup. Make sure you multiplied the right pieces together. And if you did, then maybe you made an algebra error somewhere. For TQ, we still had to solve for x. So we had 14 times 2x plus 1 and 18 times 2x minus 5. Distributing into our parentheses and solving for x, we get x equals 13. When we take that 13 and we plug it in, TQ is what we wanted. So TQ is just represented by 2x plus 1. 2 times 13 plus 1. Your final answer is 27. Now these 2 examples look a little different, right? Because our intersection is outside the circle. So we're going to use a different equation. And that equation is outside times the whole equals outside times the whole. I think some teachers like to call it like ow, ow. Outside times whole equals outside times whole. I don't know. That helps you remember it. That's great. If not, it's just a way to remember. Okay, so let's solve for x. Okay, we're going to look at each chord. I'm going to start with, we'll do blue. We're going to start with this one. Okay, so the piece on the outside is 8. The length of the whole thing that goes from here to here, that's 8 plus 19. Okay, so 8 plus 19 gives us 27. And then for the other secant here, the piece on the outside is 9. And the length of that whole thing, it's just 9 plus x. Right? We don't know what x is, but we know to find the length of the entire piece, you just add the 2 segments together. So since we don't know what x is, we can just write that as 9 plus x. Okay, so now we can say, okay, well, 8 times 17, that's 216. Distribute your 9, 81 plus 9x. Subtract 81 from both sides and divide by 9. And it was just asking us for x, and there it is. Okay. Number 6, let's find NL. Okay, so let's go step by step, one secant at a time. Let's start with this blue secant. In the blue secant, what's the piece on the outside? The piece on the outside is 10. What's the length of the blue segment, the whole thing? It's 52, 42 plus 10. Okay, now let's look at the other secant. We'll make it red. On my red secant here, what's the piece on the outside? It's 13. And what is an expression to represent the length of the whole thing? It's x plus 13, or you could have said 13 plus x. Either way, that's correct. And now we can solve for x. So we can say, all right, well, 10 times 52 is 520. Distribute your 13, 13x plus 169. Subtract 169 from both sides. And divide both sides by 13. So we get x equals 27. So now we have to find NL, right? NL is the entire red segment. So x is 27, and NL would be 27 plus 13. So our final answer, the length of NL, is 40. Okay, so now these are very similar examples. The only thing that's different is we got a few more expressions in there. Not a big deal. I definitely would recommend putting those expressions in parentheses right away. Okay, so in number 7, let's look at this first secant. The piece on the outside is 8. The length of the whole thing, well, it's just going to be 8 plus 3x plus 4. Just add your segments together to find the length of the whole thing. The second secant, the piece on the outside is 7, and the length of the whole thing, we add our segments together. And now we just play algebra. I'm going to simplify what's in my parentheses first. So we get 3x plus 12, and we get 5x plus 9, and we distribute. So we get 24x plus 96. That equals 35x plus 63. So you subtract 24x from both sides. 9x. Subtract 63 from both sides. 9x. 11x, that was silly. 11x. There we go. Subtract 63 from both sides, we get 33 equals 11x. Pen's going crazy. Divide by 11, x equals 3. There we go. Wonderful. All right, you've seen me do 3 of these examples now. Go ahead and try number 8. Solve for x first. And then once you know x, plug it in and find the length of YZ. But first, solve for x. Go ahead and do that now. All right, so this one looked a little bit like the one we did before, where we had 2 expressions. So the piece on the outside was 12. Let me find my pointer. Here we go. So the piece on the outside was 12. The length of the whole thing is this entire piece. So we use segment addition and we get 12 plus x plus 8. For the other secant, the piece on the outside is 15. And the length of the whole thing is this entire piece. So we have to add the 2 segments together, 15 plus x minus 1. Simplify inside your parentheses. So 12 plus x plus 8 becomes x plus 20. 15 plus x minus 1 becomes x plus 14. Then I distribute that 12, so I get 12x plus 240. Distribute the 15, 15x plus 210. I subtracted 12x from both sides, and then I subtracted 210 from both sides and divided by 3. So I got x equals 10. Now it asked for the length of YZ. YZ is here in our picture, and it's labeled as x minus 1. X was 10. So YZ is 9. All right, number 9. Okay, we saw this when I went over the types that you would see. Now here's an example where we have a secant and a tangent. But as long as we remember that relationship, outside times the length of the whole thing will equal outside times the length of the whole thing, then we can set this up no problem. So let's see, 18 is on the outside, and the length of the whole thing is x plus 18. Or if you said 18 plus x, that would have been fine too. For my tangent, the piece on the outside is 24, and the length of the whole thing is still 24. 24 times 24 is really 24 squared. I'm going to distribute that 18. So I get, let's see, 18x plus 324 equals 24 squared. 24 squared is 576. Subtract 324 from both sides and divide both sides by 18. X equals 14. And there you go. You're done. All right. So the idea is the same. The only thing is a tangent doesn't have a piece on the inside. So the length of the whole thing just happens to also equal the piece on the outside. Using that idea, go ahead and try number 10. Do number 10 now. All right, so first we had to set up our equation and the piece on the outside times the length of the whole. So for the secant, the piece on the outside there was 8, and the length of the whole thing is from m to p, so it's 8 plus 5x minus 1. The biggest mistake that students make on problems like this is they want to say 8 times 5x minus 1. But it's not piece times piece, it's time outside times the whole thing. So definitely make sure that you have that whole piece, whole secant, as 8 plus 5x minus 1. Then your tangent is 16. So the piece on the outside is 16, and the length of the whole thing is still 16. Combine your like terms in your parentheses, distribute your 8, subtract 56 from both sides, and divide by 40. So we got x equals 5. Then to answer the question, to find the length of Pn, Pn is right here. It's the piece on the inside of the circle. So that's 5x minus 1. X was 5. 5 times 5 is 25. Minus 1. Our final answer there is 24. Okay, we've got quite a few examples in these notes. Lots of practice for you. I will tell you that there are some challenge problems here. So I would like you to try number 11 and, no, we'll do number 11 and then I'm going to have you try number 12. Let's try number 11 together and then I'll tell you which problems were challenge problems. So number 11, we have a secant. In our secant, the piece on the outside is 27 and the length of the whole thing is 27 plus 21. We have a tangent. So that's x, and the length of the whole tangent is x. Okay. Do you see what's going to happen here? 27 times 27 plus 21 is 1,296. And x times x is x squared. We've learned how to get rid of a square root. So we just type in the calculator, square root of 1,296, and x equals 36. So this was a little different because the tangent was the variable. Okay, I want you to try number 12. Just try it. We'll see what you get. Okay, so this one made you remember how to multiply a 3x and a 3x together. So I'm hoping that you set up this first part right, 9 times 9 plus 16. And then the piece on the outside was 3x, and the length of the whole thing was 3x. So you get 3x times 3x. And 3x times 3x is 9x squared. We need to get that x squared by itself, so we divide both sides by 9. So how did I go from a 225 to a 25? I divided by 9. Okay, so here, divide by 9, divide by 9. That's why the 9 went away, and I was left with just x squared. And then 225 divided by 9 is 25. To get rid of that square, I took the square root of both sides, and x equaled 5. That was fun. So just watch out just in case you have to be multiplying an x by itself. All right, the next few problems are here for my honors students. Okay, so if you are enrolled in Geometry Honors, you should definitely go ahead and check out number 13, 14, 15, and 16. If you're not in honors, but you want to try it anyway, go ahead. They use some multiplying skills that you may not have seen since Algebra 1, but it's definitely possible. You're welcome to try them and check out the key on OMHS for the solution. If you have any questions about them, you're welcome to let me know. Questions like numbers 13, 14, 15, and 16, that algebra level will not be tested on the Geometry SOL. Okay, so they're not going to ask you to multiply binomials on the Geometry SOL. If they do, then those are just test questions, like not that don't count toward your score. So the type of multiplying that you would need to use in these is not actually tested on the Geometry SOL, but it is good to know for Algebra 2. If you have any questions about them, let me know. But again, 13, 14, 15, 16, challenge questions, honor students, definitely make sure you can do these. We've got one more idea to talk about, and that's the equation of a circle. Okay, now we have to be really careful talking about equations of circles because a circle is not a function. Okay, some of you have asked me so far, how do I graph a circle? Right, and I said, well, it's not a function. So we got to think way back to Algebra 1 when you learned what a function was. And really the easiest definition I can give you right now is a function has to pass the vertical line test, meaning for every x value, there is only one y value. But if I draw a vertical line through a circle, it intersects the circle twice. So it does not pass the vertical line test. And because it doesn't pass the vertical line test, a circle is not actually a function. So it's very difficult to type this into your standard graphing calculator, because in a standard graphing calculator, you have to enter a y equals and put the equation in. And that's not quite how the equation of a circle works. Although it is quite simple. You will like this, I think. I like it. All right. So the equation of a circle says x minus h squared plus y minus k squared equals r squared. And each of these letters represents something. HK is a coordinate. So the coordinate HK, that's the center of your circle. And R, you've probably already guessed it, that's the radius of the circle. Good news, this formula is on your formula sheet. You don't need to memorize it. It's on your formula sheet. Yay! And some questions have started to pop up about this formula sheet. Yes, you're allowed to use the formula sheet on any assessment. And that formula sheet has been posted in your geometry toolbox since the beginning of the year. Hasn't really been useful up until about now. So if you haven't been using it, you really haven't been missing out on anything. But now is the time to really start making sure that you have a formula sheet nearby. Don't write anything on it because that's cheating. But if you have a clean formula sheet, either printed and you can look at it while you're taking an assessment, or open in a new tab, you're welcome to look at that during an assessment, and I'm okay with that. You will get the formula sheet on the SOL, and I'll show you how to find it in TestNav when we start an SOL review. All right, so enough about formula sheet and SOL. We've got the equation of a circle. X minus h squared plus y minus k squared equals r squared. Okay, let's look at some examples where we can see this in action. So if they give you the center and they give you the radius, you're golden. Right, this is the easiest one that you could do, because you have this equation, x minus h squared plus y minus k squared equals r squared. If they give you the center, that's your h and your k. And if they give you the radius, that's your r. So all you have to do is plug those numbers into your formula. X minus, okay, h is 5 squared, plus y minus, k is 3 squared equals r squared. We're not going to write 2 squared. If r equals 2, then what's r squared? Well, r squared is 2 squared in this case, which is 4. So we're going to write equals 4. And you're done. That's it. An equation always has your x and your y. This is just a different type of equation because it doesn't say y equals. We're used to seeing like y equals mx plus b, right? Or y equals some formula or some equation that we can graph. I'm pretty sure Desmos will actually graph this. You know, back in my day, my graphing calculator wouldn't graph a circle. I'm pretty sure Desmos will graph this for you though, and you can check that out. Do be very careful with those minus signs. Like here in number 2, they give us the center. So I like to label it right away, HK. Radius is 14. And I know in my equation, I'm going to need r squared. So I just go ahead and figure out r squared. R is 14. So r squared is 196, 14 squared. So for our equation, it's x minus h. Well, h is -1. Okay. I don't like this minus a negative. You will never see that as an option. When you have minus a negative, that's really addition. So when you have a negative center, it's going to turn that minus into a plus. Another thing that students tend to forget, be very careful. Don't forget that's the squared part. That's very important. And then we have y minus k. K is 7, so it just says minus 7 squared equals r squared, 196. Easy peasy. They might try to get a little tricky on you. Like look here at number 3, they tell us the diameter. Okay, well if the diameter is 18, what's the radius? It's 9. And if the radius is 9, then what's r squared? 81. Yeah, so just be very careful with that. So to write the equation, I'm going to say x minus h. H is -2, so this is really x plus 2, because this would say x minus -2 squared, plus y minus k. K is -11, so this would be y minus -11 minus a negative is really plus. And we already figured out r squared was 81. Okay. Go ahead and try number 4. Tell me what you get. What do you get for number 4? All right, so in number 4, h was 0 and k was 9. Well, x minus 0 is just x. If you put x minus 0 in the parentheses, that's not wrong. But if you had a multiple choice or a multiple select or something like that, they would simplify that down. So anytime your h or your k is 0, you know, you can simplify that. X minus 0 is just x. So this becomes x squared. Y minus 9, because k was 9, equals 256. The diameter was 32, which means your radius is 16. And if your radius is 16, then r squared is 256. Then they might even try to get a little trickier on you. I'm showing you all the ways they could try to trick you. If r is square root of 47, if r is the square root of 47, we want to know what r squared is. So square both sides. Well, the square root of 47 squared, you could type that in your calculator if you really wanted to, but we've learned that the square root and the square cancel each other out. So r squared is just 47. See how they tried to trick you there? Be careful. So h is -4, k is 0. So I can say x minus -4, so it really becomes plus, squared, plus y minus 0. Y minus 0 is just y. So I'm just going to leave it y. I'm not going to put y minus 0, just y squared equals r squared. And r squared is 47. Okay, so if they give you the radius and a radical, when you square that, it cancels out the radical. And you can always just put that in your calculator if you really want to, or if you want to just prove to yourself that the r squared is right, that's okay. Go ahead and try number 6. Tell me what your equation for number 6 would look like. All right, you should have gotten x minus 15 squared plus y plus 6 squared equals 158. H was 15, k is -6, and your radius squared is 158 without the radical. If your radius is the square root, when you square it, that radical will go away. All right, let's look here. What happens if they give you a graph? We can write the equation of the circle. What do you need to write the equation of a circle? You need the center, you need the radius, and we can find both of those things from looking at this picture. The center of the circle is right here. Its coordinates is 1, 2, 3, 1, 2, 3, -2. All right, now we know HK. The radius, count the blocks. 1, 2, 3, 4, 5. So the radius is 5. Now we have everything that we need to write the equation. Again, equations on the formula sheet, you don't need to memorize it. X minus h squared plus y minus k is -2, becomes plus, squared equals r squared. Well, if the radius is 5, then r squared is 25. Easy peasy. Okay, what happens if they give you the center of the circle and a point on the circle? They don't tell you the radius. Okay, if they give you the center of the circle and the point of the circle, you're going to have to find the radius. And there's multiple ways of doing this. I'm going to show you what I think is the easiest way. And I'm going to be using the equation of a circle, mostly because that's on the formula sheet. You don't need to memorize it, so might as well use it, right? Okay, so we haven't really talked about what x and y represent. X and y represent a coordinate that is on the circle. Okay, so x and y, that's a coordinate on the circle. Okay, we've said that HK is the center of the circle and it's the coordinate of the center, and r is the radius, of course. So the center of the circle is 9, 10, so that's your HK, and your point on the circle, they gave you your XY. We need to find the radius. So I'm going to take my HK, X, and Y and plug it into my equation of a circle. X is 7, H is 9 squared, plus Y is 4, K is 10 squared, equals R squared. So let's see, 7 minus 9 is -2. -2 squared is 4. 4 minus 10 is -6. -6 squared is 36. 4 plus 36 is 40. R squared is 40. Technically, I could stop right there because I don't really need R. I need R squared. That's what's in the equation. Okay, so if that's what's in the equation, I can just say, oh, I found R squared because that's what I need to put in the equation. So your final answer has to be the equation of this circle, not just finding R squared. So your final answer, you have R squared, you have HK. X minus 9 squared plus Y minus 10 squared equals 40. This will be your final answer. This circle, or this equation of the circle, would work for every point on the circle, including 7, 4. Okay, so in number 9, I would like you to find R squared. Start with that, and then we will go ahead and write the equation. But find R squared. What is R squared for number 9? Try that now. Okay, so you should have gotten R squared equals 128 by plugging in your HK and your XY. Okay, we're not done yet. We have to actually write an equation for the circle. So let's write the equation for the circle. X minus H is 1 squared, plus Y minus K is -5, so it becomes plus 5 squared, equals R squared. And that's what we had solved for, 128. So our final answer for this guy is X minus 1 squared plus Y plus 5 squared equals 128. That's the equation of a circle with the center at 1, -5, and all of the points on that circle would work with this equation, including that -7, -13. All right, there's quite a few examples here for you. We're not going to go through every one, but I definitely urge you to practice them. Make sure that you can solve them. These are very SOL-y questions. I just made up that word, SOL-y, but you get what I mean, right? They're using lots of ideas that we've used in class to do it. What they really want you to do, okay, I gave you the shortcut. They really want you to use the distance formula to find the radius and then use that in your equation. We just used the equation of a circle instead. Okay, so I'm going to go off on a little bit of a tangent here and show you something kind of cool. Okay, so I'm not actually solving number 10 right now. Here's your equation for a circle. This should feel familiar to you. Okay, you have a circle. Here's the center. You have a point on the circle. Here it is. We call that the radius. The radius is the distance between the center and the point. Do you remember a distance formula? I'm going to write it slightly differently. I'm going to write it d equals x1 minus x2 squared plus y1 minus y2 squared. How do you get rid of a square root? Oh yeah, you square both sides. So if I do that, now I have x1 minus x2 squared plus y1 minus y2 squared equals the distance squared. Well, the point is xy and the center is hk. So what if I made this x1, y1 and this x2, y2? So now I have x minus h squared plus y minus k squared equals the distance squared. But what was this distance again? Oh wait, that was the radius of the circle. Ta-da! There's your equation of a circle. So if you don't remember the distance formula, first, shame on you. You should know the distance formula by now. But if you don't, the circle equation is the distance formula in disguise. So if I said, find the distance between these 2 points, you could pretend those 2 points are a point on a circle in the center and find that radius. And that would be the exact same thing as using the distance formula. Pretty cool. All right, we still have a few more examples here. What happens if they give us the circumference or the area? Well, let's see. I'm going to write the equation of a circle up here. X minus h squared, y minus k squared equals r squared. Great. We know the center. Cool, that's hk. So all we need now is r, or r squared. The circumference is 6 pi. Remember the equation for circumference is 2 pi r. If you don't remember that, that's also on the formula sheet. You don't have to memorize that. All right. Well, if the circumference is 2 pi r, that means that 6 pi equals 2 pi r. Divide both sides by 2 pi. Pi's cancel. The radius is 3, which means that r squared is 3 squared, 9. So our equation here, now run out of space. Hold on a second. Our equation will be x minus h, oh, that's -1 squared, plus y minus k squared equals r squared. There it is. This is why we practiced using circumference to find the radius and so forth in the very first lesson of Unit 10. Okay, so pretty simple. If they give you the circumference, use that circumference formula to solve for the radius. Use that radius to find r squared, and then you can use that in your equation of a circle. Go ahead and try number 13, 14, or 15. Pick one. Pick one of the three, okay? And then tell me what your answer is in the pause. So pick one of 13, 14, or 15. You don't have to do all three of them. Just pick one of them. Oh, I spoke too soon. All right, find the one on the screen that you chose to solve for. Did you do the other circumference problem where you had to set the circumference equal to 2 pi r, solve for the radius and then find the radius squared? Or did you pick one of the area problems? Okay, so in number 14, the area was 16 pi. So you had to find the radius. Remember, the equation for area is pi r squared, a little different than circumference. And I only found r squared. I didn't need to go all the way to finding r because my equation uses r squared. So once I knew what r squared was, I could plug that right into my equation. Same with number 15. Okay, make sure you can do both. Make sure if I give you the circumference, you can find the radius, and if I give you the area, you can find the radius. We did this back in day 1 notes, but just a little practice doing that here and then putting that into our circle equation. Okay, so now we could go backwards, right? What if I gave you the equation? Could you tell me the center and the radius? I personally like to write the equation of the circle right either above it or below it, depending on like how much space I have. So in number 16, I'm just going to write x minus h squared plus y minus k squared equals r squared. And now I can see exactly what matches with what. Right here, the h's match. So h is 5, k is 1, r squared is 64. So if r squared equals 64, let's do that here. R squared equals 64, then take the square root of both sides to find the radius, 8. So here our center is 5, 1, and the radius is 8. Number 17, we have to be careful with those minus signs. Okay. Notice that in number 17, this is a positive 7, but this is a minus h. So what does that mean about our h value? It's negative. So this becomes negative 7. The k value, oh, that's still 2. The radius squared, r squared is 324. So to find just the radius, square root both sides, and the square root of 324 is 18. Be careful. It tricked me the first time I looked at this. It's asking for the diameter. So if the radius is 18, what's your diameter? Well, it's twice that. The diameter is 36. Okay. Number 18, this looks kind of strange. There's no h value. Oops, r squared. There's no h value. What number represents nothing? 0. So h is 0. K, those signs match. They shouldn't match. It should be a minus. That's what I get for talking and writing at the same time. There we go. See how our signs don't match? So that means that k is negative 10. So 0, negative 10 is our center. Radius squared, so r squared is 42.25. When you take the square root of both sides there, we get 6.5. That's the radius. This is asking us for diameter. Diameter is 2 radii, so the diameter is 13. Go ahead and try number 19. What's the center? What's the radius? Try 19 now. So the center of this circle is at 6, negative 11, and the radius, well, just square root 58, right? Because r squared is 58. Take the square root of both sides, and if you put that in your calculator, ooh, it's ugly. So just leave it an exact number, square root 58. Kind of like how we saw at the beginning of this idea back here, when they told us the radius was square root 47 or the radius was square root 158. That's okay. So for this one, our radius was just square root 58. Nice. All right, number 20. This is like the overall, if I had to ask you the equation of a circle and I wanted you to use as much information as I have taught you as possible, this is the question I would ask you. Okay, just because this is going to use midpoint formula, this is going to use our distance formula, which is hidden in our circle equation to do this. Okay, Not hard, just step by step. So we're going to write the equation of a circle, meaning our final answer is going to be in this form. They're telling us the endpoints of the diameter, and that's it. They're not telling us the center. They're not telling us the radius. So we got to calculate both of those things. Okay. So I like to first start with the center. Let's calculate the center. If you have a circle and you have a diameter, the diameter goes through the center of the circle. Well, this is a radius. This is a radius. They're equal. That point right there, the center of the circle, how do you describe it compared to the diameter? If you said midpoint, you're right. The center of the circle is the midpoint of the diameter. Remember the midpoint formula? x1 plus x2 divided by 2, y1 plus y2 divided by 2. So these are the endpoints. This is an x and a y, and this is an x and a y. There's no HKs here because they're just endpoints. They're not the center of the circle. So let's calculate the center by finding the midpoint of the diameter. x1 plus x2 over 2, y1 plus y2 over 2. That's negative 24 over 2, negative 12. 10 over 2 is 5. So now we know the center of the circle. The center of the circle is the midpoint of the diameter. If you need to write that down somewhere, be my guest. Okay, so this is the center of the circle. This is our HK. We almost have what we need. We need the center of the circle and we need the radius. So now this problem has become just like these problems were. Now we know the center, and we actually know 2 points on the circle. You can pick whichever point you want. I'm gonna pick, let's pick the first point. You can pick whichever one you want. You could have picked the other one, it doesn't matter. Pick 1 point, you got your center. Now we have what we need to find the radius. So x, okay, that's the negative 14, minus k, or h, x minus h, so negative 14 minus negative 12, so that's plus 12, plus y, 1, minus k, 5, squared, equals r squared. Well, negative 14 plus 12 is negative 2, negative 2 squared is 4. 1 minus 5 is negative 4, negative 4 squared is 16. That equals r squared. 4 plus 16 is 20. R squared is 20. All right, so now we can write our final answer. The equation of the circle, x minus h is negative 12 squared, plus y minus k is 5 squared, equals r squared. Okay, so what happens if they only give you the endpoints of the diameter? If they only give you the endpoints of the diameter, you have to find the center of the circle. The center of the circle is the midpoint of the diameter. Once you know the center, that's your HK, then you pick one of the 2 points, and it doesn't matter which one. If I had picked the negative 10, 9, I would have still gotten r squared is 20. You pick one of those 2 points, you use the center of your circle, and you plug that into the equation of the circle to find r squared. Once you know r squared, you can use that r squared in the center of your circle to write your final equation. Your final equation will always have the x and the y in it. The hk and r squared will be numbers, they'll be filled in. Very nice. All right, that takes us to the end of the lesson. I definitely recommend doing the practice problems on OMHS. And we've covered a lot of equations today. So you're gonna see the play, pause it, pause in just a moment, and it's gonna give you what I call cheat sheet for all of the equations. It has all the equations from Unit 10 on it for you. There's a blank one and there's a key, and I will also post this to OMHS for you too. You may use it to practice. You may not use it on a test. So you can use that little cheat sheet to help you practice it and get all your equations and formulas straight, but you may not use it on a test. Okay, I hope you find it helpful in your studying. And if you have any questions, please let me know. I am happy to help you. That's what I love to do. Have a great day, everyone.